let's understand projectile on an inclined plane. Let's say we have an inclined plane over here which is inclined to the horizontal at angle theta. And what we have done is, from here we project a body with the velocity, initial velocity u, and this is making angle alpha with this inclined plane. As a result, this goes from here to here and strikes over here. Now we are interested in our usual kind of things, that is, what is the time of flight from here to here, what is this range, that is the distance it travels up the inclined plane, and what is this maximum height and all those things. Our emphasis right now shall be on understanding the basic concept, that is how to deal with such questions. Now to find the time of flight of this projectile on an inclined plane, or what is the range of this projectile up the inclined plane, what we do is, instead of taking the x-axis and y-axis like this, let's say x-axis over here, y-axis over here, we have been taking the axis like this. We had been taking the reference frame like this, but for the ease of understanding, what we do in this case is we slightly rotate them. That is, we take x-axis in this direction parallel to inclined plane, and we take y-axis in this direction. Now instead of taking the x-axis and y-axis like this, we have slightly tilted it. Now once we have rotated it, and this is x-axis and this is y-axis, when the body goes from here to here, we still find that is sy is going to be equal to 0 along the y-axis. That is, y-axis over here, the x-axis over here. So let's say we call this as x-axis, and let's say we say this is y-axis. This is angle 90 degree. So when the body has gone from here to here, this is origin we are taking it. So over here y is equal to 0, and over here also, that is y is equal to 0. So when the body goes from, let's say, O to A, the displacement on the y-axis is still equal to 0 only. But what about the acceleration? What is the acceleration on the y-axis, and is there any acceleration on the x-axis? Let's see that. So we are interested in, if this is our new x-axis and this is our new y-axis, what are the accelerations along this new x-axis and what is the acceleration along this new y-axis? Whatever the case may be, let's say a body has been thrown like this, Earth says, I am going to pull you down in the vertically downward direction. So the value of g at any instant is going to be vertically down only. So g is acting in this direction only. X-axis over here, y-axis over here, this is x-axis, this is y-axis, g is acting in this direction. We are interested in finding the component of this g along this new x-axis and this along this new y-axis. If this is theta, this is 90, so this is going to be 90 minus theta. So this is 90 minus theta. But this and this, they are perpendicular to each other. This is x-axis, y-axis is perpendicular to this. So this angle is going to be theta. When this angle is going to be theta, it means the component of g in this direction is going to be g cos theta. And the component of g in this direction is going to be g sin theta. It means if g is in this direction, vertically downward direction, then along the y-axis, the accident due to gravity component is g cos theta, and along the x-axis, along this x-axis, acceleration component is g sin theta in this direction. Rest is simple. What we have been doing earlier, let's say how we have been using the equations of kinematics along x-axis and along y-axis, we shall be doing exactly the same thing in this case also. The only change is that is now we are going to have an acceleration on the x-axis also. So if we wish to write what is the equation from O to A, we write Sy is equal to Uyt plus half Ayt square. We are just bothered about, let's say, what are the equations, how to write the equations. We are not much bothered about the final result. When the body goes from O to A, then the displacement along the y-axis is equal to 0. Like over here at O, y coordinate is equal to 0, and once again when the body reaches over here, the y coordinate is still equal to 0. So there is no change of level along the y-axis. As a result, Sy is equal to 0. What is Uy? What is initial velocity along the y-axis? So what we do is we break this velocity in two components. This angle is alpha. This is a new horizontal or new x-axis. So this way it is going to be u cos alpha, and this way it is going to be u sin alpha. Once again, if we have to take the vectors, so this is x-axis, this y-axis. If this way we are taking it as positive, this way we shall be taking it as negative. If this way we are taking it as positive, this way we have to take it as negative vectors. So when the body has gone from here to here, Sy is equal to Uyt plus half Ayt square. O is our initial point of observation. What is initial velocity along y-axis at O? At O, initial velocity along y-axis in the upward direction. In the upward direction, we are taking it as positive. So it is going to be u sine alpha into t plus half acceleration on the y-axis. Now acceleration on the y-axis is g cos theta, and it is in the downward direction. Downward direction is negative. So minus g cos theta into t square. So this is the equation we get. T is not equal to 0, so we can cancel it. So this comes out to be u sine alpha. This comes over here is equal to minus half g cos theta into t square. So this comes out to minus u sine alpha is equal to minus half g cos theta t square. So this comes out to be 2u sine alpha upon g cos theta is equal to t. Once we had found the value of time, that is t, time of flight from here to here, obviously this stands for time of flight only. And now we are interested, that is how far up the plane this will go and strike this inclined plane. That is, we are interested in Sx, this new Sx, x-axis is like here. We are interested what is Sx or what is SO to A, what is that? So what we say is, we use the equation Sx is equal to uxt plus half Ax into t square. In our earlier cases, when the x-axis were horizontal and y-axis it was vertical like this, the value of acceleration along the x-axis it was equal to 0, but not in this case. So over here, Sx is equal to ux. Ux is initial velocity along the x-axis, that is u cos alpha. So this is u cos alpha. T we can put it from here plus half. Now Ax, what is the acceleration along x-axis? Acceleration on the x-axis is g sine theta, and it is in this direction. In this direction, it means it is negative. So it is minus g sine theta into t square. We can put the value of t from here to here, and we can find the value of the range on the inclined plane. So the only new kind of a thing which you have to consider in the cases of projectile on inclined plane is that you have to make the components of g along the x-axis and along the y-axis. This you take it as x-axis, this you take it as y-axis, and rest is you can use the equation of kinematics as you had been using in our earlier cases.